Our next two circular functions have a period of pi instead of a period of 2 pi. Also, unlike the cosecant and secant functions, their graphs are not U-shaped. However, they do have vertical asymptotes. We will begin by looking at the sketch of y equals tangent of x. So for y equals tangent of x, what I would like to remind you is that tangent of x is equal to the quotient of sine x divided by cosine x. And this is important for many reasons, but there are two in particular that I want to discuss right now. When cosine x is equal to 0, that means the tangent will be undefined, and hence we would get vertical asymptotes. And that occurs at negative pi over 2, pi over 2, and 3 pi over 2. When sine x is equal to 0, that means that the tangent of x will be equal to 0. And therefore, that occurs at negative pi, 0, positive pi. And then from there, still thinking about the fact that tan x is sine x over cosine x, we can determine that when they are both positive, sine x and cosine x, then the tangent is positive. And that as cosine x gets smaller and sine x happens to be getting bigger, that fraction, sine x over cosine x, is going to go off to infinity. If I look backwards into what would be the equivalent of the fourth quadrant, you'll know that cosine is positive and sine is negative, and therefore their quotient is negative, and it's going to go off towards negative infinity. Now, in particular, you may remember from your special angles that the tangent of pi over 4 is 1, and the tangent of negative pi over 4 is negative 1. The tangent's period is only pi, and therefore we complete one cycle in that range of pi. It is discontinuous, and there is no amplitude, but it does display odd symmetry. Now what I'd like to do is take a look at the graph of y equals cotangent x, and remember that we can think of that as cosine x over sine x. And therefore, when the cosine x is equal to 0, which is at negative pi over 2, positive pi over 2, cotangent will also be 0. And when sine x is equal to 0, then the cotangent will have vertical asymptotes, which occurs at negative pi, at 0, and at positive pi. And then finally, when we look at the ratio, and the ratio I'm talking about is cosine x over sine x, we can say, again, in terms of their positive and negative values, when they are both positive, cotangent is positive. But as the sine is decreasing and cosine is increasing, then that fraction will be increasing. And likewise, vice versa, the cotangent would be decreasing as the sine increases. So we know that it will have a positive value in quadrant 1 because cosine and sine are in fact positive, but in quadrant 2, which would be from pi over 2 to pi, we know that the cosine is negative and the sine is positive, so cotangent will be negative. And again, the cotangent has a period of pi, there is no particular amplitude, and it displays odd symmetry. Well, now that we have an understanding of the shapes of the functions y equals tangent x and y equals cotangent x, let's look at a method that we will use for graphing the tangent and cotangent functions in a general way. Graph y equals 2 tan x over a 2-period interval. So what we would do first is graph y equals tangent x. And the graph of y equals tangent x has its vertical asymptotes at pi over 2 and negative pi over 2. It passes through 0, and it's increasing from left to right. If we then carry this out one more full period, what we would say is that at pi, it is 0, and at 3 pi over 2, we have another vertical asymptote. Well, how does that apply then to y equals tan of 2x? Well, the 2 in front of here is, of course, going to affect it horizontally. And in particular, this 2x will cause it to be shrunk in towards the y-axis. In fact, what's going to happen is, instead of the tangent, which has a period of pi, we will now be looking at the tangent of y equals tan 2x having a period of pi over 2, which means we'll complete a cycle in pi over 2. It also means that the vertical asymptotes will become, instead of negative pi over 2 and positive pi over 2, they become negative pi over 4 and positive pi over 4. So instead of trying to draw it on there because I'll have so many lines, let me redraw the tangent of 2x here. So at pi over 4, we will have a vertical asymptote. At negative pi over 4, we will have a vertical asymptote. It will still go through 0. So here I have one complete cycle, and let me draw one more cycle, which is to say that this point on the original tangent curve, which is at pi, would now be pi over 2. And this original vertical asymptote, which is at 3 pi over 2, would now be at 3 pi over 4. So we draw our curve increasing from left to right. And what I want you to notice is that we've completed 2 complete cycles of the tangent curve in the same amount of space that we were only able to complete 1 cycle of the tangent curve. So we've gotten 2 in here, 1 in there in the same distance. Well, now it's time for you to try a problem. Remember that in a previous section we looked at translating basic graphs vertically. I would like you to do the following problem, which involves a vertical translation of the basic graph y equals tangent x. Graph the function y equals 1 plus tan x over a 2-period interval. Pause the video while you work on this problem, and when you are finished, restart the video to check your solution.